Hey everyone, good morning and good evening. Okay, let's start with today's session and let's see what exactly we are doing today. Last time what we did, we have gone through what is Kubernetes and we have seen how do we set up Kubernetes from scratch on a VM. That is something we did last time. Today we'll focus on AKS. Okay, we'll go back and set up the Kubernetes again, guys. That is maybe in tomorrow's session I'll do it because I may have to set up Helm chart and HTTP on top of it. So that is something we'll do later. But in between, let's go through Kubernetes service provided by Microsoft. Now, if you go and look for Kubernetes service, what is the difference of launching a Kubernetes on the portal and creating your own Kubernetes from scratch? So this is where you have everything set up done. You don't need to manage your master node. You don't need to manage the services. Everything is managed by the cloud provider. Whether you use AKS, whether you use GKS, that's Google Kubernetes Service, whether you use EKS, that's Elastic Kubernetes Service by AWS. Okay, everything is managed by the provider themselves. You don't even have access to the services, guys. That's a different story. If you want to do something on this Kubernetes, you simply go and launch a single node cluster depending upon your requirement. How many clusters do you want? So you can go simply launch a single node cluster and you can start doing your work. That simple it is. Okay, so if you read through this, Kubernetes service to create manage Kubernetes cluster, Azure will handle cluster operation. What does this mean? The setup what we did last time, setting up Docker, on top of it setting up kubectl, kubeadm and kubelet, then setting up the code DNS, all those setup what we did by ourselves, manage the thing by ourselves. This will be all managed by Kubernetes providers. So who is the provider over here? In my case, Azure is the provider. Okay, so let's go through it and let's see how exactly a Kubernetes cluster can be created. So let me create a single node cluster, and today we'll do all the processing on the single node cluster itself. Okay, so I'm just creating a single node cluster, name it as DevOps Mela-RG. I'll preset configuration, I'll keep it standard for now. You can even go for dev test. Okay, now you can even select this dev test. It's totally depends upon what exactly you're doing. Okay, you can stick with dev test, you can stick with standard. Standard will cost you a bit. Dev test comes in free tier. If you have free tier applicable, then it comes in free tier. Let's name the Kubernetes cluster as DevOps Mela AKS. Region East US, availability zone could be anything. I'm not dividing into availability zone. Access tier, if you see, it is free. So what is free? The cluster management is free, but you will be charged for the VM. So basically, even though if you're creating a AKS cluster, guys, in the backend, Microsoft creates a VM. Okay, you'll not even come to know, but that is what the reality is. A VM gets created and a master node gets created on top of it. Okay, automatic upgrades, I'll keep it disabled. If you want, you can keep it, but whenever it's always recommended, whenever there is a upgrade, it should do an upgrade. See, update the cluster to the latest patch version with set minor version. This is the node size in the free tier, 4 vCPU and 16 GB of memory, guys. This is minimum in the free tier, but if you want, you can go to something else also, even much smaller size like this one, 2 vCPU, 4 GB of RAM. You can even select that. Scaling method, there are two ways, manual and auto scale. Auto scale, so if you if you're keeping it manual, guys, you need to go and manually upgrade your cluster size. That should not be recommended in production. Production should be in auto scale, because whenever there is a load, whenever there is some new resource getting created, you should have a flexibility to spin up a new node so that the pods can be automatically created on that particular node. Okay. If you're not giving the resource, how Kubernetes will go and create the pods automatically? So yeah, in reality, we should always have auto scale so that the node counts depending upon whatever requirement you have mentioned. Based on that, the node count will automatically go and increase. Okay. I'll keep it manual for now. I don't want to keep it auto scale. Nothing will happen because will not be launching that big something, but we can keep it one. So only one single node cluster will be created. This is my agent name. This is the size. How many pods I can create on top of it? I can create 110 pods. Okay. Networking kubenet. So that's the internal networking of Kubernetes. If you want, you can even use Azure CNI. Integration, if you want to integrate your container registry, I don't have a container registry right now because I've deleted the previous one. But if you have a registry, you can also integrate that registry over here. Let's review and create. So this is what's happening right now, guys. We are just creating a single node Kubernetes cluster, and that easy it is. Once your Kubernetes cluster is up, you can log into the Kubernetes cluster and you can start working. So within 5 minutes of time, you will be able to launch a Kubernetes cluster of yourself. The only difference is the management part is completely taken out. You don't need to manage anything. Everything will be managed by the provider themselves. You will get the worker node. In this, what exactly you get? In this, you get a worker node. You take the worker node, log into the worker node, and start deploying, creating your pods, and do whatever you want. Make sense? This is what Kubernetes is all about. AKS is all about. And on top of it, what best you can do in AKS, the upgrade is done automatically. So your kubelet and everything the services gets updated by the provider themselves. The max you do is you scale up, scale out, you manage your pods, and those things what you do. So you don't have much control basically on such services. Okay. So that's why I have created the bare metal Kubernetes first, giving you the glimpse what exactly Kubernetes is in reality. Then we are coming to this AKS part. Now let's wait because this cluster creation will take around 5 minutes of time. So today what I'm doing, there are a couple of things we'll be doing today. Last time, if you remember, we have created a pod, a single node pod, where we have deployed an Nginx application. Now that is not the right way of doing things, guys. In Kubernetes, always you need to have a deployment created. You need to create deployments. Now what exactly is deployments? Because if the last time, if you remember the pod which we have created, if I go ahead and delete that pod, no other pod will get recreated. The pod will not get recreated. And what did I say when I was introducing Kubernetes? Then Kubernetes works on self-healing. Like if any of the pod gets deleted, it will go and recreate the pod. But nothing as such was happening last time. So all this recreation and everything is done using deployment. So this deployment is nothing but the deployment used to tell Kubernetes how to create or modify instance of the pod and that hold containerized your application. So deployment is basically, it's telling when you create a deployment, under the deployment you can have n number of pods created, and on that pods your application will be deployed. Now what this deployment will do, the deployment will manage your pod creation. It will scale up your pod creation. It will scale out your pod creation. It can replicate your pod like in your, if you have mentioned in your deployment that I want one pod, one replication of pod running at any given point of time. So even though if you go and deploy, delete the pod manually, or is some XYZ reason the pod got deleted, deployment will make sure that the pod is recreated automatically. If you want to deploy, like if you want to deploy your application at once, everything will be done at the deployment level. Now you will have your deployment. Inside your deployment, you will have your pods. These pods will run your application basically. So whatever you want to do now, you will not do at the deployment. You will not do it directly at the pod level. You will do at the deployment level. You want to deploy your application, deploy at the deployment level. This will get replicated at the pod level. You want to scale up your number of pods, you do at the deployment level. Automatically these pods will be increased. You want to delete some pods, do at the deployment level. Automatically the pods will be deleted. If somehow this pod gets stopped or deleted, then this deployment will make sure that if we have mentioned that two pods should run 24/7 for this application, like if I have mentioned the replicas as two pods, so what will happen, this deployment will make sure that there are two pods always available. So basically this what exactly deployment does for you. Deployment is managing your application on the pods. It is used to tell, it will tell the Kubernetes how to create, modify instance of your pod. So basically the management part is done by this deployment. Deployment can scale the number of replicas pod. It can enable rollout. It can also update code. It can also do a rollback. Yeah, rollout and rollback is also done at the deployment level. Suppose you have deployed version 1.1. So it can depending upon the rolling strategy, whatever strategy you have, it will go and deploy this 1.1 on these pods. Now, because of some XYZ reason, you need to fall back to the older version. That also will be done at the deployment level. So in reality, guys, in reality, you will be not be creating pods directly. The way we did it last time, created the pods directly. That is something you will not do in the reality. In real time, you'll be creating deployments. Make sense? Anyone? Any doubt? Any confusion? What is deployment? So deployment is basically, just imagine it is a container in which your application is deployed, and at the container level you're managing everything by yourself. The deployment will manage everything for you. Okay, so this is how your AKS looks like,
Quick
guys. This
question.
is, yep.
Is deployment same as master node?
No.
Okay.
Master node is where all your Kubernetes services controllers are running. That is managing your complete Kubernetes. Deployment is one of the object which you create inside your worker node, not also on the master node, on the worker node. That deployment is managing your application running pods instances. Like your application requires 4 pods. Okay, so you create a deployment and that 4 pods will be created. So those 4 pods are getting managed by that deployment. You will even create a deployment for yourself. So that 4 pods of yours, it's getting managed by that deployment. Now, if something happens to your pods, like you want to scale up, scale out, upgrade, all this can be done at the deployment level. You want to deploy your changes, you want to deploy your code, you will be deploying. So no, you will not go to the individual pods to deploy your code, because that will be tedious, because I'm just taking an example of 4 pods. In reality, there will be 100 pods running your application. Just imagine you're deploying your changes on one pod at a time. That is not feasible, correct? So what you do it at the deployment level. The deployment will automatically deploy all your changes to those 100 pods. So whatever you do at the deployment level. You will not even touch the pods in reality. If something happens, if you want to debug, you may go inside the pods and see things, but in reality, you will do things at the deployment level. Okay, that is how Kubernetes manages your applications, running applications.
Okay, thank you.
So deployment is basically you're creating a structure, and that will make sure that it is managing your pods and applications for you. Okay, I'll go and we'll do the demo, then you'll understand more what exactly this deployment is. Okay, let's see this AKS, guys. This is your resource group. This is the Kubernetes version which it is running. This is the API. We got the network plugin kubenet. This is one node pool what we have. Now if you go to the namespaces, we got very similar to what we did when we were setting up things. We got kube system, kube node lease, kube public, default. Kube system, we all know this is the place where all my master node services are running. Okay, now you can see the workloads, you can see the node pool. So this is what the node we have created. Okay, now basically you don't have much to do, frankly speaking. You can go and add multiple pools over here. You can upgrade, downgrade. So this is what you can do most. You can have your workloads defined. What are the workloads? See, code DNS, what are these are the nodes which is running right now on your system. On which namespace it is running? Kube system. Autoscaler, connective agent, metric server. Do you see any services which we had previously, like controllers, API? You don't see anything. Why? Because that is something we don't have control. This is completely managed by Kubernetes itself. Azure itself. So you don't have control on what are the services running, what are the master node services running. It's all managed by AKS. So if you see, you just got the network thing right now. What that is what you can see. Do you have all the pods running? See, there are so many pods already running on the cluster. You got core DNS, connectivity, Azure IP, cloud node, Azure file, kube proxy, metric. These are some services which you can view. So this is all you're viewing from the portal itself. Okay, daemons set, you have the pod, you have the replica set, you got your deployment. See, do you see this deployment over here? This deployment tab is basically showing the deployment. We haven't created these are system generated, guys. This is the Azure has created for managing services. So they have created deployment basically. Inside this deployment, you got this pods running it. Okay. Now let's go and log into this. There are multiple ways to log into AKS cluster. One of the easiest way I'll find is going to this cloud shell, and you can use bash, PowerShell, whichever you want. So let's take with bash for now. This will create a storage basically, and this storage will have, and it will give you a shell. This shell will has everything, like it will have the CLI setup and everything done. You just need to connect to your Kubernetes cluster and start working with Kubernetes. Okay, the same thing can be done from your local. You need to do a easy login from your local shell. Also, you can do the exact same thing which I'm doing it from the cloud shell, and you can connect to your AKS cluster. Okay, so what we will be doing, the single node cluster which we have created, will go and log into that cluster, and then we can run all our Kubernetes commands basically. Now, in order to log in, this is the command we need to run. This is basically getting credentials, resource group, and the cluster name. The resource group is DevOps mailer -rg. Cluster name is DevOps mailer AKS. Hopefully I'm right. Let me minimize this. DevOps -rg, DevOps -AKS. Perfect. This is the, so basically what it will do, it will get you the Kubernetes credential, AKS credential, and that will be stored on your local. Then you can run all your Kubernetes commands, and you can do all sort of Kubernetes operation then post that. Okay. So let's go to the shell again. AKS and all is already installed by default, so you don't need to go and install AKS and do AZ login and all. Those steps are skipped. This is because you're logged in, you're opening this shell inside the portal itself. So you don't need to do all this, guys. So that part is skipped already. Now if you see this merged, if you go to this config, you can see this. Your credentials are right over here. So you have fetched the credentials and you have placed those credentials right in this local path of yours. See this. This is your credential. Now you can go and run your kubectl commands. Get nodes. See this. Now kubectl is also installed, guys, because you're using Cloud Shell. Your kubectl is also installed, because if you don't have kubectl, if you're doing things from your local, you need to go and install this kubectl also on your local. kubectl is a command line utility tool for managing Kubernetes. So that's why I'm not doing it from a local, because I don't have kubectl on my local basically. Okay. Now if you want to see any running pods, get pods. There's nothing in my default namespace, but if you go to other namespace, now if you want to view all the namespaces, these are the 4 namespaces. It's the same information which I was showing you from the portal. Default namespace is the place where we can do our things. If you want to create other namespace, we can do that easily. And these are some system namespace. Now in this, if you go to kube system, now if you want to go to kube system, how do you go? kubectl get all, and I'll give the namespace as kube system. You can see everything what system is doing. See this. These are everything which is running inside your kube system. Yep. Questions? Okay. These are all the pods. So these are all system. You don't have to do anything in this. I'm just showing you this is what system has created. And these are the services. These are the pods which is already running on your Kubernetes cluster right now. Okay. Now let's go and create our first deployment. Let me go and create, because everything you do now, this will be done as a deployment. Now last time we have created a pod. Let me just create the pod again for you. kubectl run. We have created this pod, image nginx pod we have created. Let's name this as web nginx. Okay. Now this is something we got created last time. Okay, I got this pod running in. Now what did I say? That if anything happens to your pod, if the pod gets stopped, or if the pod is not responding, a new pod should get created automatically. That is something
I have been used before. Perhaps was 6060 pod you used before.
Sorry.
Check it out. It wasn't. So if we do next start, is the pod in use now?
Are you talking to us? Excuse me. I think he's speaking to someone else. Okay, no problem. So I was saying this is the pod which we have created last time. Now if I go and delete this pod or stop this pod, do you think this pod will be recreated? Let's try that. I go and kubectl delete pod. Let's name this pod as web nginx. Pod deleted. Now if I can run the pod command again, no resource found. The pod is not recreating. But if you go and see my PPT again, the introduction of Kubernetes, in the self healing, what did I mention? That if the running pod gets deleted or stopped, Kubernetes will try to recreate that for you. But over here, it's nothing as such happening. This is because you have not made this pod, this particular web server of yours, part of deployment. If you would have created this as a deployment, in the deployment, if you would have mentioned that I want one replica of the pod running any given point of time, then this thing would have been running. If I would have stopped the pod again, it would have created the pod for you again. Okay, that is why we need, if you want to deploy any application in Kubernetes, you need to create a deployment. Without deployment, you cannot deploy your application on Kubernetes. Just keep that in mind. Deployment will manage the creation, deletion, modification, scale up, scale out, everything for your application. And that is done automatically. Okay, let's go and create a deployment. How do you create a deployment, guys? So I'm showing you two ways right now. We are running imperative commands. So these are ad hoc commands which I'm running right now on demand. Okay, same thing we can do it through declarative approach also, wherein you will be writing the YAML files. So I'm not writing the YAML for now. I'm just going through the ad hoc command, showing you how quickly you can do things in Kubernetes. But can you do this? Can you run this imperative command in reality? Like in the production? The answer is no, guys. If you want to create deployment, always create config files. Don't run this command from ad hoc, because you'll not have any proof what exactly you have done, what you have created once you log out. And tomorrow, if you want to make changes to your deployment, you don't have that file. So it's always a good practice to go and write your configuration by yourself, not through ad hoc commands. Ad hoc command is good for administrative purpose if you want to do something very quickly. Okay, at that time you'll be running these ad hoc commands. Okay, make sense? Let's go and run through this imperative command. Then later I'll be creating config also. But today let's focus on this ad hoc commands. Okay, how do we create deployment? The command is kubectl create. Okay, you don't need to remember this command. Even I don't remember. Okay, what do? I always take help of this. So when you run kubectl, you don't know anything. You just do help. You get all the list of commands. Everything you get it. Now what I'm supposed to do? I'm doing a create. I want to create a deployment. So what I do, then I go and run this create. Then I do again a help. I don't know how to create. What you want to create? I want to create deployment. If I come down, see, do you see deployment? They create a deployment with the specified name. Do you see this deployment? There's so many other things you can create. So let's go and create a deployment. Create deployment. Now I don't know what all things I need to put in deployment. Again, I do a help. This is how you'll be defining replicas. This is how you'll be defining pods. Do you see this command over here, uses command? This is what you need to go and do it. That's a create Kubernetes command, deployment command. I'll just follow the exact same thing. I'll show you this format I'll follow, and I'll show you. Okay, this is the command. Now I'm just following the same command, kubectl create deployment, name of your deployment. So this is I'm basically web app Nginx web app we are launching, correct? Image is Nginx. It will go and fetch the Nginx latest. Now this will go and create your, what it will do, it will go and create your deployment with the Nginx pod. But you have not mentioned how many pods do you want. How many pods do you want? You have not mentioned that. So you can do a define as replicas equal to at least one. I want one pod to run this Nginx web server at any given point of time. Image spelling mistake. Okay. Okay, this is, you don't need to use this flags, uppercase, lowercase, guys. Keep it all lowercase. Okay, now if you see this, created. Uppercase is not allowed, only lowercase. Now if you see this, the deployment is created. Now if you go and how do you see your deployment? The command is kubectl get deployment. You can write the complete deployment or you just write deploy, that is more than enough. You can also write deployment, it does the same thing. Okay, now you got this deployment. Do you see you got one WebEx Nginx? Inside this you got one hyphen one, not hyphen, that's a /1. That means there is one replica of your pod running inside this deployment. If you want to know more about your deployment, you can just do a simply kubectl describe deploy, the name of your deploy. Describe will basically tell you everything about what's happening inside. See this. Scaling replica set, scaled up replica, so one replica got created. Strategy, rolling update strategy. What did I say at the beginning? That rolling update strategy is the default strategy, what you have. Namespace, it got created in the default namespace. This is the label we have given. This was the name of the deployment, which we have given. Okay, and how many replicas did I set? One desire, one updated. What did I say? Any given point of time, I want one pod to be at least running on this deployment. Now, if you see, go and see, there will be one pod running it. See, there is one pod, and this is running a Nginx web server. Now, what did we do last time? When we deleted the pod was not getting recreated. Now, if I go and delete the pod now, do you think the pod will be recreated? Guys, what do you think? If I go and delete this pod, do you think the pod will be recreated or not? Anyone? What do you
Yes,
guys think?
it
It
will
should be
recreate.
correct, because we are managing things from the deployment level, not at the pod directly now, correct? Let's see that. Let me kubectl delete pod deleted. Do you see this? 4 seconds ago, started running again. Because you have mentioned inside your deployment that I want one replica of your pod running any given point of time. So whatever you do, you delete, stop. So this is why exactly I'm showing this deletion, because in reality, suppose you have your application running 20 pods. If something happens to any of one of the pod, you will not go and view it manually. The deployment will manage things automatically. It will try to recreate, it will try to restart. All these things will your deployment will automatically try. Okay. Now let's go back to deployment. Get all. So basically, get all command will get you every whatever services running in your default namespace. So you got your pod running. This is the default service. I'll talk about this in a bit. Now, if you see this, it has created a replica set also. All thanks to this replica set, your pod is recreating, guys. Along with deployment, we have created a replica set. Replica set is nothing but it's a controller which will go and make sure that the desired number is always met. This replica set is doing that for you. Not exactly deployment. The deployment is creating a replica set, and the replica set is making sure that the desired number is always met. Okay. Now, as I said, you can scale up, scale out deployment. How do you do that? Very easy. You can just do the command kubectl scale. There's a command called scale, and you can just give the name of your deployment. What is the name of your deployment? Web Nginx. Okay, and you can just mend the replicas. How many replicas do you want? Suppose I want 4 pods to run my Nginx web server. Now, if you go and run the command kubectl get pods, see you got 3 more running, which is running a Nginx web server now. If you want to scale out, same command, change the replicas to 1. Only one running. That fast Kubernetes is. Understood what is deployment? Importance of deployment now. So tomorrow when we deploy any application, we'll be creating deployment basically. Okay. Now second part. How do you access this Nginx web server? How do we access this Nginx web server? Can I go and access this Nginx web server? Will it be available on the public IP? There's no public IP first of all. If you see this, this is your CIDR, this is service CIDR, this is your DNS, this is your Docker bridge. How do you access your application now? Unlike your VM, there's no public IP to go and access. How do you? Now, can I do it on my local? Let's do a curl and see if my Nginx is up. Do you say fail to connect localhost port 80 after 0? Couldn't connect to the server. I'm not able to connect to this Nginx. Why? This is because we haven't created any services. Now, what is services? Okay, that is something we'll go and understand. So before that, anyone wants to speak about what is services? Anyone, guys? So if not, then I'll talk about services in Kubernetes. Basically, it will enable communication between components. It could be the components could be inside or outside application. So your communication, like this is, I'm trying to do a communication. There's an Nginx web server running on my Kubernetes. I'm trying to connect to that particular web server from outside. This is I'm outside, guys. I'm not logged in inside the node. This is I'm outside. Okay. So Kubernetes services enables communication. So it helps application to connect with other application or user. Like if you have multiple modules running and if you want to have those communication established between those pods, then you need to create services. Okay. And if you want to connect your application from outside world, then you need to create services. So whether the communication is within the pods, whether the communication is from the outside world, whether the communication is between two different nodes, then you need to have services created. Services can enable front-end application to interact with back-end application. Services can also enable front-end application to communicate with back-end application. So basically what services that it can help you enable communication between multiple pods, multiple nodes, and the communication from outside world. So if you want to do anything as such in Kubernetes, you need to go and create services. Without services, you cannot do anything. Okay, making sense? Now there are three types of services which you will come across in Kubernetes. One is cluster IP service, node port, load balancer. What exactly are these three? Let's understand that in details. Let's go to a paint diagram. Now, what is the current setup? What I have right now? I have something like this. I got this one single node cluster created. I got this one node cluster. Okay, this is what I have right now. And this one node cluster, I have my deployment created. Inside that deployment, I got this pod running. Let me have something close over here. Okay, I got this Nginx pod running right now. That is hosting my Nginx. Now, what did I try with the curl command? With the curl command, I'm somewhere over here in this world. And I was trying to connect to this web server, which is by default not permitted. okay, which is by default not permitted. Now, what exactly how this services will help me? Okay, the first type of service is a cluster IP service. Now, what exactly is this cluster IP service? So the cluster IP service is the default service. Like whenever you go and create a service in Kubernetes, the service which gets created is a cluster IP service by default. If you don't specify what service you want to create, the default service which gets created is a cluster IP service. So it gives you a service inside your cluster. Okay. So now what exactly it means, it gives you service inside the cluster. Like if you got multiple pods running in, suppose I just had one pod, one deployment, but just imagine this is your Nginx web server and this is your database server. For example, I'm just giving an example to you on the same. And if you want to establish communication between these two, if you want to establish communication between these two, then you need to have cluster IP service type created. If you want to establish the communication between these two pods, internal communication I'm talking about, then you need to create which type of service? Cluster IP type service. Okay, this is the, again repeating, cluster IP service is the default Kubernetes service. It gives you a service inside your cluster that other apps inside your cluster can access. Now this is the communication happening in between. Now just imagine this is your front end, this is your back end, and all this communication, if you want to have the communication, this is how the communication will happen. This is cluster IP. Other type of communication. Let me create one more node. I haven't created that. Let me have one more. Imagine there's one more node. Now, imagine there's one more node. This is just imagine we have created my second node. Node is what, guys? VM, correct? Where your things are running, correct? Anyone? Any confusion with what node and all is? Second, imagine this is a cluster. Now imagine, let me remove this DB thing from here. And imagine this is also your front-end application, your Nginx. So you got multiple Nginx server running, okay? This is front-end. Now over here, I'm creating a backend. This is where your DB is there now. This is what reality is, guys. You will have your DB server kept separately, very separate from your front-end application. Because this front end, this will get managed directly from outside world. People will be able to hit these servers. But your DB server should be always kept separately, should not be exposed to the world. That is how the architecture gets created. Now, the problem is how these two guy will be able to communicate with this DB server. They need to communicate, correct? How will they communicate? Because these are front end. These are your web application. These are your web applications. And they need to internally connect to your DB server to getting data from the DB. Now with cluster IP, the internal communication is done. Now this is two different nodes. This is one VM. This is other VM. So this is going outside your VM now. The traffic is going outside your VM. Internal cluster IP. If such traffic which is going outside your VM, anything as such, if you have, this will be done using something called as node port. The service type which you will be using in this will be node port. A node port service is the most primitive way to get external traffic directly to your services. As the name implies, guys, node port, what exactly it does, how it works, it opens a specific port on all the nodes, and any traffic that is sent to that port is forwarded to the service. Now, what exactly node port does? It will go and open a specific port. So what will happen? It will go and open a port like something over here, like something, the port will be 31000, and all the traffic, so from the front end, whatever traffic is coming, it will be directed to this particular port only. So all your traffic will be, so on the VM level, on the cluster level, this port will get open. All your traffic will be getting directed to this 31,000 port which I have mentioned over here. And then the traffic will be sent to the DB server. So this node port basically opens that particular port for you. Now for the node port, there is a range of ports which you can assign. The range is from 3008 to 32767. This is the range which you will be assigning, guys. This is only, so you can use a port anything in between. So 31,000 is between this, correct? So this is what node port does. What it will do, it will open a port at a specific cluster. It will open a port at the node level, and then all your traffics will be directed towards your DB server using this particular port. And this is the range which is permitted. You cannot go anything. You cannot have 40,000. This is the only range what Kubernetes understands. Make sense? Anyone? Any doubt? Any doubt? Any question? Okay, this is how node port works, guys. Now, last but not the least, the third type, known as load balancer type. What is the third type? Load balancer type. Now, till now I haven't talked about how my external communication will happen. This is all internal we are talking. Within the pod node, outside the node, this is all internal we are talking. What about my external communication? How do I communicate from outside world? This is internet. You are the user. How do you communicate? This communication will happen using the service type called load balancer. Now, load balancer, as the name implies, it also behaving like a node load balancer for you. So you have something like this service type created at your node level. All the traffic is getting redirected to this particular load balancer service. This is type load balancer. And load balancer also does the load balancing thing, like it will go and direct your traffic to the available node, available pods. So it can also do something like this for you. So I got two Nginx web server running, correct? So it can also direct traffic to such Nginx. It can direct 50% traffic, 50% traffic. This way also you can do, or depending upon the availability, it can also direct the traffic. Suppose this pod got deleted, stopped for some reason. All the traffic will be directed to this pod then with the help of the load balancer. This will be done automatically, guys. So load balancer service is a standard way to exposing service to internet. This is a standard way for exposing service to internet. If you want to expose your service to the internet, then the type which you need to use is load balancer. So with Azure load balancer, which we can route the traffic from external to the services. So this is the standard way for exposing service to internet. Three types. Repeating myself again. Cluster IP, if you want to enable internal communication between the pods. Node port if you want to enable communication between nodes. Load balancer if you want to expose your ports to the internet. Got it, guys? Anyone, any confusion with what exactly these services are all about? Are we good with these three types? Anyone has any doubt, any confusion with these three types? No doubt. Let's go and create this then. Now, if you go and look into your, if there's any services, so basically this is the command kubectl get service. You see something called cluster IP. So this is by default, this is for internal communication for Kubernetes. So this is something I have not created. This was by default created. Now I can go and I got a Nginx web server. How do I access that Nginx web server? That is the question. Now we need to go and create a service first. How do you create a service? I don't remember. So kubectl expose. Expose is the command for creating services. So just do a help. Now in this, do you see this uses? This is the whole command which you can run it. Now I'm just following this say exact same thing, okay? kubectl expose name, file name or type name. So this is basically I'm doing it for my deployment. So I need to expose my deployment. So what is the name of my deployment? It's web Nginx. Okay, that's the name of my deployment. So before that, you need to have deployment written over here. Deployment and name of my deployment given. What is the port? Do you want to which port do you want to expose? Port 80 because Nginx listens on port 80. What protocol? If you don't mention any protocol, TCP will be the default protocol. Target port number. Target port number, if you don't mention automatically, this target port number is nothing but it goes and creates this for you. Even though if you're using load balancer, a port will get opened at your node level. So basically, I'm saying 80. So your request will come on 80, but in the backend, the request will go on this target port number by default. Even though if you're not creating node port, guys, this is something will happen. Direct 80 port will not get opened. This is how the communication will happen. Your request is going on port 80, but when it enters the load balancer, the request goes to this particular port, whatever port. I'm just giving an example to you. Automatically the port will be assigned in between. Then the request will be gone over here onto any of your port. Then it will go out. When it is going out, it will go again back on 80. That is how securely you will be doing ingress and outgress. Traffic will be coming inside your pod, going outside your pod. Okay. So that is what the target port. I'm not defining any target port. I want Kubernetes to assign the target port to me. Okay. Name, give whatever name you want to give. I've named it as web Nginx SVC. Okay. External IP. Okay, you cannot see my screen. Sorry, wait. Perfect. Okay. This was the command, and this is my command. Okay, this was my command. So I'm just taking an example from the upper part. So this is exposing deployment, name of your deployment, port you want to expose, the name of your services, target I'm not defining, and most importantly, the type. What did I say? By default, if I don't define this type, what will happen? By default, cluster IP will be created. And if you create a cluster IP type, you'll not be able to access basically. So what type we need to create? We need to create load balancer type. Okay, this is how you'll be exposing your services. Done. Now if you go and run this command kubectl get services, you don't need to write services again and again. SVC is the short form. And then do you see this web-based nginx? And now most importantly, do you see this public IP? Now you require public. We all agree that if you want to access anything from outside world, you will need a public IP. So this load balancer type is creating the public IP for me. Do you see the type? Load balancer. Now can I access this application now? Curl on port 80. See, port 80. And see, do you see a node port also got created? Why? Because directly on 80 you'll not be able to access. This is something Kubernetes does it. Do you see? You're getting Nginx page now. Welcome to Nginx. Can I access this from outside world? Yes, why not? Nginx. This is how, in reality, this is how the traffic is coming on port 80. Thanks to load balancer, the traffic is going to some node port that was 30548 something, and it is getting diverted. So load balancer type is the most efficient type if you want to expose services to your internet. Okay. Now, where is my, now if you want to see what services you created, what type it is, you can also describe kubectl describe svc and the name of the services. See, the namespace got created in default namespace. This is the label which we have used. Type load balancer, IP, load balancer IP, port which we have exported, node port. Do you see this node port? 30548. Endpoints. This is how you'll be describing services. Make sense? Any question? Any doubt? Anyone with this service type? No questions, guys? Okay. Now, if you want to go and delete your services, you can go and delete. Recreate again. You can go and recreate. Now, all this, whatever I did, can also be done using declarative approach. That means you can go and write your YAML files. So let's go and create the same exact same deployment. We'll do it using YAML now. Exact same deployment, we'll do it using YAML. Now YAML we all know. YAML is very basic, we all know. Now let me delete the deployment. Like if you want to delete everything now, guys. So you need to go and delete your deployment now. Pod deletion and things will not work. If you want to do anything, go and delete this deployment. kubectl delete, deploy. Now things will be deleted. Your pods and everything will be deleted. Nothing will be running. Your services will still be intact. The services are not deleted. You need to go and delete the services again. kubectl delete svc and the service. Now if you see, everything got removed from your default namespace. Nothing is there. No pods, nothing, no replica set, no deployment, no svc. Everything is whatever we have created till now in this last 1 hour. Everything is deleted and removed. Now this deletion takes time because the reason is there is a public IP assigned. After deletion, this public IP is also getting freed up. Okay. Now if you go and see this command kubectl get all. There's nothing. This is only the default cluster IP what you see, which my master node is using. Let's go and do the exact same thing, but this is a pretty easy stuff. Let's do it using YAML now. YAML, I can basically make use of, let me create the name as Web Nginx. Okay. And let me just give you basic open Visual Studio Code. You can use anything, guys. Visual Studio, Notepad++, Atom, whatever editor you want. There's nothing that you need to stick with Visual Studio Code. It's because we got Visual Studio already installed and it got YAML language support. I'm using it. That's it. That's the only reason, nothing else. Open a folder. This is a folder which we have created on the desktop. So let me open this. Now, how do you create deployment using YAML? Okay, because that is the way of doing. Ad hoc command is temporary. If you want to have something done, then you need to have this created. So I'll have something called deployment.yaml file, YML. You name it as YML, you name it as YAML, it's completely fine. Now, there are four top level fields in Kubernetes if you want to write YAML. The first field is API version. Okay, API version is basically will be at the very top, wherein you will be defining the API. So depending upon what resource you're creating, your API will change. Now, for suppose if you're creating our deployment, so the API version is V1. This is there on the documentation, guys. You don't need to remember anything. So the API version is B1. If you're creating a replica set, the API is something app V1. If you're creating a deployment, the API is app V1. If you're creating a services, the API is V1. This is how this API version will change depending upon what you're doing. Okay, so what you're doing, you're creating a deployment. So apps V1. So if you're creating, so this is how Kubernetes will understand what services you're trying to create. Make sense? This is the first level. The second is kind. What kind of service you're creating? Is it a pod? Is it a deployment? Is it a replica set? Replica set. Is it a services? So that type, what exactly you're doing, that will get defined over here in the kind. Now see, I'm writing this, giving a semicolon, giving one space in between. This is because YAML is straightforward, guys. You don't need to do much. So this is my deployment. Third field is metadata. Third field is metadata. This is basically the name of your pod, the labels and everything will come over here. Okay, like for example, I'm giving a name. Remember the what command did we run for creating a deployment? It was kubectl create deployment, name of the deployment web app nginx, image nginx, replica equal to 1. This is what we did. Huh? So this name what you see over here, that is metadata information for me, and this create deployment, that is kind for me, and the API version we have mentioned. So it's just try to replicate whatever you did from the command line into a YAML file. Now this name will come over here. This web app Nginx name will come over here. Simple. Now where do you put this image information? This will come inside your spec. The fourth place is spec. This spec is basically your, so this container, this Nginx is running inside a container. Your container information will come over here. What pod will be running, what application it will be running, what web server it will be running, everything will be defined inside this spec. Understood? So this is how you try, always try to replicate things this way. Don't go and try to write things directly. Just try what exactly we did, how exactly we did, and how things will be done. That is how you should always do a thing. Okay. Now in your spec section, you will have all your information defined, what exactly needs to be created, what needs to be done, all those things will be defined inside your spec. Okay. Now inside your spec, you can have container information. So you will have something like containers, because this is running inside a container, correct? So we'll name it as container, and I'll have the container information. So you can give it a name. This is your image name now. This name what you're giving, and name it as Nginx image. This is nothing labeling of your image, because this image will get downloaded. So I'm just giving a name, whatever name you want to give, you can give it. Now actual image name will come over here. So what is the image I want to call? Nginx, correct? Automatically it will go and fetch Nginx image for me. And I can have any port open. If you want to have, what is the port? Nginx listens on port 80. So you can have container port open over here. This is something extra you're doing. Container port 80. So this is inside your container. These are the information which is there inside your container. Now you guys will say you have not mentioned replicas or anywhere. How will my deployment know how many pods needs to be created? We haven't mentioned any replica anything. Okay, so that goes at the top of your spec. So this spec is for, which is for your container. Now there will be one more spec wherein we'll be mentioning the replicas. Okay, so we go at the top, we create one spec, and this spec, what you have, what you see, this becomes child of this. So I'll just move it a bit inside. Okay, now this spec over the top, what you see, I'll have a replicas created over here. Replicas, how many replicas? One for now. Okay, now the point is, this has become child of this. Now when my deployment runs, okay, like suppose if the replica, if the pod is stopped, and how will my deployment will come to know which pod to create, which image to fetch? So for doing that, you need to give your deployment some sort of template to follow. The deployment should have some sort of template which the deployment can automatically follow, and it can create the pods for you. Okay, now this is the template. Now this is whatever you see, this is what my all my pods should get created using this template. Now that is where a concept of template comes in picture. So your deployment will follow template. Okay, now this spec will be child of this template. Now see, it's inside now. Now the deployment has to follow this template. Like suppose if there's new pod want to create, how it will be creating? Have you given any template to follow? Like use this template to create this pod. Like if I'm telling you guys to go and create this pod for me, I need to give you a template that this is the image, this is the pod, this is the port number which you need to expose, and things like that. if I don't give that information, will you be able to create a pod for me? The answer is no. The same concept over here. For you need to give some sort of template to the deployment to go and create the pods. So that template needs to be defined. But the important question is how this template will know that this replica belongs to this image. This is with the help of selector. We need to have selector defined. Selector is nothing but it's a naming convention, guys. It's a standard naming convention which you will give. So I'm creating a selector over here and I'm giving a name to it. I'm giving a label to it. Labels, match label. I give a name. Now this name which I'm defining over here, like my app, this name I can use wherever I want now. Wherever I give this name, now that means I want to create this deployment with one replica. And this same naming, whatever name I have given over here, the same naming I will be using inside the template as a metadata information now. Metadata. Now I'll give this name as labels. I'll call this name as labels. So which name I'm calling? I'll call this name, basically. Labels, this should be in lowercase. App, my app. Now let me, I know you guys got confused now. Let me just how this file will be read when you're executing this. It will read from the top in a sequence. It will look for API. Okay, this is app v1, good. Kind deployment, good. Name of your deployment, web app nginx, good. Then it will read the specification first. It is asking creating one replica. Okay, then it will look for selector. So this is the selector what we have defined, my app. Now it will look for this name which you have defined over here inside your template. Now we went inside the template and we saw the name matching. If there's a mismatch, if your template name labels which you have given and the labels which you have defined, if there's a mismatch, your deployment will stop then and there. Nothing will happen, basically. Then this is matching. Now it will look for the template inside the template, what spec we have defined. Like what exactly, this is where your pod is getting created, actual pod is getting created. Now the template, the name has matched. Now the template will look into this spec. Okay, I need to create a Nginx web server and I need to open port 80 on that particular port. Done. This is how your deployment will be created using declarative approach. This is the same flow you will be using for every application deployment. Nothing much will change. Okay. Now if I go and run this on my AKS, or how can I do it? I can do this, upload this file, that file I require, which is there on my desktop. Now if you go and see this, I got this running. Now running this, I can just simply do a kubectl apply -f and the deployment. Now apply, there are two ways of creating kubectl apply and kubectl create. Create is basically it will go and create any new services or resource for you. Apply can create that resource for you as well as it can, if there's any modification in future, it can also do the modification for you. So that's why the command kubectl apply. Run this. Hopefully there's no typo, there's no spacing issue, anything as such. There was nothing as such. Kubectl get deployment. Do you see this, guys? Got created with one replica. Do you see this? You got this pods running. Now if you want to edit, how easy it is. If you want to add something, you don't need to just go and open your deployment file again. come down, change this to 2. Then just run this apply again. Done. Configured again. See, kubectl get pods. Do you see how easy it is to manage now with this deployment file of yours? Make sense, guys? Any questions, any doubt? Anyone? Do we have anything in the chat? Okay, no. Now this was, we have created what? We have created a deployment. Same way you can go and create a service, because how do you access? You need to have a service created. So I name it as service.yaml. Okay. In the service.yaml, it's the same thing, guys. Fourth thing, API version. For creating service, the API version is v1. Kind, you're creating the kind service. Mention the service. Metadata, give your service name. If you want to give a service name, give a name as, name it as my web service, whatever name you want to give. Now the spec part, you can mention the type, what type of service you want to create. Load balancer, correct? Okay, which port you want to expose? 80, correct? You want to access things on port 80. Now, very important, how Kubernetes will come to know that this service which you're creating, this service you're creating for this deployment, with the help of this selector which you have defined over here. So selector is basically giving a naming convention to your deployment, and wherever you want anything to do with this deployment, you need to call this selector. The same thing we did in over here in the templates also, correct? So if you want to let your service know that this service is getting created for your deployment, basically, so you need to have that selector mentioned over here inside your service. This is the selector which we have mentioned. Now it's the same command, guys. If you go and look into the command expose which we ran, kubectl expose, then deployment, you need to mention your deployment, name of your deployment you need to mention. The only difference is I'm mentioning the selector what we have defined over here, that selector what we have defined, the naming convention what we given to your deployment, that naming I'm calling over here. And then you define the port, then you define the type, the name of your, what is the name? This name I'm giving. And you need to define the type. Load balancer. That easy it is. See, the exact same thing I've replicated inside as a YAML file now. Now just save this, come back to your AKS, upload it, service.yaml. Now if you see, if you see, I got service.yaml file also, kubectl apply -f service.yaml file. Done. Now if I do a quick check kubectl get svc, I should see a public IP coming in. Once I have the public IP, I can go and access my Nginx web server, which we have just created. See this. Let me open it in a new tab because you'll not understand anything what's happening. Okay, you will get your Nginx web server. Now this is the right way the way we have written the deployment and service, this is the right way how you will be able, in reality, you will be creating deployments, services for deploying your application. Tomorrow, I'll show you how do you deploy a custom application. Remember, we got .NET application in the ACR. That something will create a service. The only difference will happen is in your writing a deployment. Over here, in place of this Nginx, which is getting downloaded from a public source, you will have your ACR link over here. That's it. That is the only thing will change in your entire deployment, and nothing will change in your service. The only thing changes 5000 because your .NET application, the custom application listens on port 5000. That is the only thing will change, guys. Nothing else will change. Exactly the same. Now let me give you a shortcut. Now till now I've given you the long cut of creating things. Let me give you a shortcut basically. So this is what we use during our examination, like when we give Kubernetes examination. So Kubernetes examination is not, administrative examination is not MCQs, guys, wherein you just have questions and 4 answers and you need to select. No MCQs, it is live. You need to go and set up things like this way. Okay. So over there, you will not have time. Basically, you will not have time to run this, write this deployment and things like that. So over there, what we do whenever we get such questions to create deployment using imperative way and all, what we do, we run the ad hoc command first, like create deployment, the name of the deployment. We run the ad hoc command like this way, nginx, and what we do, we make use of dry run. So dry run basically will not go and deploy things for you. It will give you a template, a deployment template. It will create that deployment template for you and it will give it to you. Okay, it will not execute anything. So dry run will basically not execute anything. It will just create that particular things for you. So if dry run is the way, this is the flag equals to client, and you can save this file into a YAML format somewhere on your local and name it as webnginx.yaml. What exactly I'm doing, I'm creating a deployment image with Nginx image, and I'm just doing it. If you want to mention replicas, you can mention that also, guys. Now this will, when I'll execute this, nothing will happen basically. The only thing will happen, I'll have a webpack nginx.yaml file created. See this. Name is required. The name it is web deploy. So this is how you give the naming. Done. Now if you go and look, do you see there's a YAML file got created? Let's go and open this YAML file. Do you see this? Your deployment got created. Exact same thing. The only thing is you need to remove few things if you want to execute this. This timestamp needs to be removed. I've removed extra. Wait. If you want to use this, remove this timestamp and remove this strategy. Remove this resource status. That's it. You're ready. The deployment file is ready. If you want to run this, kubectl apply -f web. See, deployment ready, created. Getctl deploy. Got this created. Same way, services also you can do. You can do the exact same thing with your services with dry run. So this is what we do during the examination, because in examination you'll not have time to write this deployment from scratch. So using this dry run method, we do things in Kubernetes. Okay. So I have not showed that before, because if I show you shortcuts, you'll not follow the long way. And long way, something will take you to the long run. Shortcut will, this is for you, your benefit. Once you're comfortable doing things, then you can definitely use shortcuts. But initially, when you're learning, you need to do from the long way. Do it from the very scratch. Okay, I'll be sharing this deployment files which I've created today, guys. Okay, make sure to go and practice by yourself. Launch this Kubernetes cluster, and make sure you do things by yourself. Okay, any question, any doubt, please do let me know before we wind up for today.
I have a few questions.
Perfect, tell me.
First question, that last example you just demonstrated using the OYAML flag.
Mm-hmm.
Could you have defined the service along with the deployment imperatively and then do the OYAML output as opposed to doing it separately?
No, if you're running it through imperative command, you cannot run. So I got your point that can we have one single file in which I will have my deployment, I will have my services. Yes, definitely you can have it. Not denying on that. But yeah, if you're doing through dry run, you cannot have two commands included for doing a dry run. You'll have to run the deployment command first. You'll have that YAML created. You'll have the expose command second. Then if you want, you can do a inside the same file. If you want to direct the YAML, it's up to you how you want to do it. So yeah, both the commands cannot be executed at once. You have to run one command at a time. But just to answer, if you can have a same YAML file for both, yes, definitely you can do it. You make use of the three dashes. If you remember, we can have three dashes at the top in YAML always. So this is one. I can have one more three dashes over here. And what I can do, I can basically have this part copied, pasted over here also. But this is not at all recommended, guys. You will find everywhere this is the play, this is the way they are doing. This is how they do. So what will happen, this deployment will get created first, then this SVC will be created second. This is quite possible. In YAML, this is be considered as one script. This will be considered as second one script in YAML. Yeah, both are possible, but I'll never recommend such things. Always have a separate file created, because in reality you'll have so many things created and everything is there in the same file. It becomes very clumsy to manage. So if you have a separate file created, then the kind of a structure and framework what you're following. But it's again depends the way how the developer is writing, how you are, your technique of writing. It's totally depends upon that. Okay, make
Uh,
sense?
Makes sense. Sounds good. If you have time and if you want to do this next class, that's totally fine. But I was wondering if you don't mind going over the load balancing port and the node port, yes, port numbers and how they get mapped to each other.
Okay, so did I delete the paint? Okay, no problem. See, load balancer type, service type is basically you create the load balancer type when you want to connect to your services from outside world, like from internet. Node port is basically for internal communication between the nodes. Okay, now how this mapping happens, this is your internet. And just imagine this is a cluster. Inside this cluster, imagine you got a port running your web server. Okay. Now, what did we do? We created a node port load balancer type. I have not created node port. I have created a load balancer type. So this is my load balancer. Imagine a load balancer type we have created. Load balancer. Okay. we have created. Now the request, this is my Nginx web server which is running. The request comes on my service. The request is coming on some sort of public IP or IP on 80. We can have 80.443 depending upon 80. But the request, the same request doesn't goes internal to 80. The request from 80 gets converted into some node port. So the request over here will reach. This is how the request, HTTP will not be there. So the request will be your from local host, it becomes to something 31003, 31,000. Let's take it that way. Okay. But this is how the mapping is happening from port 80. From front end, the port is 80. When the request is going to the back end, the port is 31,000. So from 80, the port mapping is happening on 31,000. Are we doing this port mapping? No, this is automatically happening using Kubernetes. Now again, the response now. Now the response goes to your service. Now response goes to your service. That will be on the local host because this is an internal communication. Okay, this is not an external communication that will be using public IP. It will be either the local host or the domain name or the private IP depending. The request will go to the 31,000 again. Now this is where sending the response back. Now from here, the response will be sent again, will be on HTTP pub IP 80. This is how in reality, whenever you are doing any external communication, this is how the communication and the port mapping happens in the
So
backend.
is 31,000, is that considered a container port or node port?
No, contains, that's a node port. So that's your VM. Imagine the node which you have created. At the node level, this pod will be this particular IP port will get open, not at the container level. Container, we are exposing port 80 that it responses on port. If there's a request coming from port 80, then this will respond on port 80. This 31,000 is at the node. This is your VM. Imagine this is a VM, a virtual machine. On the virtual machine, I'm opening the port 31,000. Imagine if I would have set up this cluster on VM, I would have opened this port in my network rules. I will go to the inbound traffic rules in networking and I would have opened this port 31,000. I'll show you tomorrow. We'll set up a cluster and I'll be deploying my application, basically the custom application. So at that time I'll have to go in, because why did I not open this today? Because that was a KS cluster that is completely managed by Kubernetes, Azure. We are not doing anything on that. So this port got automatically open. But in reality, when you have a bare metal wherein you're setting up Kubernetes from scratch, you need to go and allow this firewall rule. At the firewall, you need to allow this port 31,000. Then only the request will come inside, or else the request will not come. Make sense? So this port is at the node level, not at the container level. Don't get confused.
Okay, thank you. That helps a lot. Appreciate it.
No problem. Okay, guys, anything else? No. Tomorrow we'll have cluster setup again done, and we'll deploy a custom application, the .NET application, whatever the one which you're following till now. And then tomorrow I'll introduce you to Helm charts. Okay, guys, thank you very much. Make sure to practice this. I'll be sharing the YAML files which I've created. Go and spin up the cluster again, and I'll share you the commands also, guys. Whatever commands I've executed, I have to write it down in somewhere in total, and I'll share you those commands also. Okay, that's it for me. Thank you very much. Let's meet up tomorrow and let's continue with Kubernetes topics. Bye bye.